Hello, I'm Cami. I'm now going to share with you all about my project proposal. Thanks for the advice given by Professor Yang. Improvements have been made in three major areas. Firstly, more literature supports have been gathered. Then, I revised my research methods so that it becomes closer to design research, which involves more flexible procedures. I have also made some adjustment to the use of evaluation methods. Now, let's go into the detail of my research. The topic of my research is using inquiry-based approach and metacognitive tasks to teach lower achieving students in Hong Kong secondary school. The statements of our research topic are: higher order thinking skills such as inquiry skills are important 21st century skills that one should acquire. Fostering higher order thinking skills is also an important educational goal. On the other hand, advances in learning sciences shows that metacognitive knowledge and skills can enhance the learning of students. Here is my problem statement. In Hong Kong secondary school education, the banding system classifies students into three bands, and band 3 students are always being regarded as low achievers, LA. Various studies have shown that some teachers hold low expectations toward LA and exclude them from higher order thinking tasks, as they think LA can't understand those tasks. This poses serious educational implications. It violates the goals of education, widening the gap between LA and HA, leaving the LA behind. Regarding the above problem, the purpose of my research is to incorporate inquiry-based learning activities into secondary 3 biology curriculum of a Band 3 local secondary school and evaluate the effectiveness. To introduce reflective assessments to the experimental group and then evaluate the outcome. There are mainly 4 sections in the literature review. Firstly, there were studies which identify within teacher variability in which teachers tended to emphasize higher order thinking when teaching HA more than when teaching LA. Some teachers did not believe that higher order thinking tasks are appropriate for LA. Kishler, Swelder, and Clark also pointed out some findings from PBL studies in their review article, suggesting that higher order thinking tasks, such as PBL, are not necessarily useful and effective for students' learning. In contrast, Soher and Norrie conducted a research and found that higher order thinking tasks and LA are not mutually exclusive. What's more, the studies show that when using scaffolded inquiry-based approach in teaching, the improvement of LA was more significant than that of HA. Milo Silver and Lin also share similar thoughts that appropriate scaffolding of the PBL task can prevent students from failure and promote the active construction of knowledge. In trying to explain the poor academic performance of LA, Campion suggested that this can be attributed to the lack of metacognitive skills. Later, Wright and Frederickson pointed out from a study that metacognitive knowledge and skills are teachable, and metacognitive tasks can enhance subject knowledge and thinking skills of students of all academic levels. The importance of metacognition to teaching and learning in biology was also highlighted by many researchers. We then move into the methodology part. In my research, participants are 2 I3 biology classes, Class 1 and Class 2 in a Band 3 secondary local school. Class 1 is the controlled group while Class 2 is the experimental group. 2 chapters are chosen from the curriculum to teach with inquiry-based approach. Chapter 1, Studying Biology, which will be covered in the first academic term. Chapter 4, Movement of Substances Across Membrane, which will be taught in the second term. There are 2 hypotheses of the project. Hypothesis 1. Inquiry-based curriculum can be successfully implemented in a Band 3 school in which students' performance on both subject knowledge and inquiry skills will have significant improvements. Hypothesis 2. Students in the experimental group who will do the reflective assessments will have better results in subject knowledge and inquiry post-test. Inquiry tasks are introduced in Chapter 1 and 4. The inquiry tasks are scaffolded, and a 6-step inquiry approach will first be explicitly modeled by the teacher when teaching Chapter 1. The reason of using scaffolding and the 6-step inquiry approach is that scaffolding involves coaching, task structuring, and hints without giving students the answer, and these can help to break down complex tasks into manageable and accessible tasks to students. For the reflective assessments, only Class 2 will be involved. First, teacher will guide students to reflect on their inquiry process by using prompting questions related to the 6th step of inquiry. Students need to explicitly write down their inquiry process in the reflective assessment, for example, the feasibility, limitations, and deficiencies of their experiments, the ways to reduce experimental error, etc. Reflective assessments will be done and collected after each chapter. For the evaluation method, subject knowledge and inquiry pre-test and post-test will be used. The subject knowledge test tests students' concepts related to Chapter 4, while the inquiry test includes thought experiments. Students are asked to propose alternative hypotheses, design experiments, make up some data that they think they might get if they were to actually carry out the experiment, analyze the data, and draw conclusions. Pre- and post-test results of subject knowledge and inquiry skills of Class 1 will be analyzed using paired t-tests to determine the effects of inquiry-based approach. The results change in subject knowledge and inquiry post-test and pre-test for both classes will be compared using unpaired t-tests or ANOVA to check the effectiveness of the reflective assessments. In this slide, I have outlined the general flow of my research process. Improvements have been added to the preliminary design to make it better. Firstly, as the inquiry test is newly developed, pilot tests should be done with a few students before the research. My preliminary research tab is a quasi-experiment. Now, this is more like a design research. In my preliminary design, the inquiry tasks are heavily scaffolded by teachers. Teacher explicitly presents the 6-step inquiry approach and repeatedly reminds students about the 6 steps. In a better design, only Chapter 1 inquiry tasks are heavily scaffolded. Then after Chapter 1, students' worksheets and reflective assessment will be evaluated to identify the strengths and weaknesses of the inquiry processes of students. Interviews can also be done with students to track their progress on scientific inquiry after Chapter 1. At the same time, teacher will keep a reflective journal to record how each lesson goes. For example, students' motivation or participation and their contributive discourse during lessons. All these can help teacher to decide the extent of scaffolding for Chapter 4 inquiry task. For the evaluation plan, my preliminary design only used quantitative method, while in the better design, qualitative data collected from the reflective journal can also be used as indicators for students' learning. Besides, when analyzing data from the two classes, ANOVA is a more suitable statistical method than the t-test. Here shows some of the research limitations and considerations. The length of intervention can be longer to improve validity. However, time and resources are limited. Conflicts of interest may occur when experimenting my own students. Teacher, researchers should avoid bias towards the different classes. Except for the reflective assessment, researcher must ensure that other interventions are the same for both classes. In order to be fair, the reflective processes will be modeled and reflective assessment will be given to the controlled group after the research. That's the end of my proposal presentation. Thanks for your time and patience. Please feel free to leave comments or ask questions.